What's up, guys? Nitty-gritty Maths here, and today we're learning about Rolle's and mean value theorem. And we'll start off with Rolle's theorem, which states that if there is a differentiable function, so between any 2 points, A and B, there's at least one number where the derivative at that point is equal to 0. So it's saying that at this point, so we'll say there's a function, A here, B there, there's a point here, C, that the slope there is equal to 0. And that's very true because, as we can see, the derivative here, if we take every tangent line at A, it's going to be positive until we reach 0, so there's going to be a maximum, and then it decreases. So if we draw the number line, or rather a closed interval, we'll say there, A and B, between A and B, there's going to be a point C where the derivative is 0. From here to here is positive. From here to here is negative. That's why there's a maximum. And that's why we use Rolle's theorem. Rolle's theorem is very useful because it shows that when we do curve sketching, everything's consistent. So after this, I'll be doing a curve sketching video. So now we'll do mean value theorem. I'll donate that by MVT. And it says if there's a function f of x and it's defined and continuous, so if it's continuous on a comma b, but it's a closed interval, and differentiable on the open interval a comma b, then there's at least one number c. So in between, so a is less than c, but c is less than b. Then there's a formula where the tangent line at C is equal to the secant line between B and A. So I'll just write that there. The secant line between B and A. And this is correct as well because if we draw the graph, I'll just need some space here. If we draw the graph, and we'll say, what is it? We'll draw it like that. Then we'll use our marker, C. So there's a tangent line at C. And we'll draw that. That's there. We'll call that A and B. In between this interval, right here, there's a value C. And they're both going to be parallel to one another because they're the same. The slope of the secant line here is going to be equal to the slope of the tangent line. So that's why we can use the mean value theorem. That's very useful because when we have to solve a question, as I will show you right now, on a closed interval, it's very useful for that equation that we just used, that I just showed you. So we'll say f of x is equal to 4x cubed minus 8x squared plus 7x minus 2. Alright, so right here, and we're going to have a closed interval at 2 comma 5. Alright, that does not look like a bracket. And so 2 comma 5. So, and it has to, so determine all numbers C which satisfy the conclusion of the mean value theorem for the given function and interval. So the first thing what we're going to do here is write our equation, f prime of C is equal to f of B minus f of A over B minus A. So right here, this is going to be our B, this is going to be our A, since it's from A to B. We go from A to B, and we'll plug in the numbers. So f of B is just plugging this number into here, and we're going to get f of 5 is equal to 333. You can use your calculator for that. F of 2 is equal to 12, and we know B is 5 and A is 2, and we'll say the derivative of f of x equal to 12x squared minus 16x plus 7. Since we're using C, we'll put in C for everything else. 12c squared minus c, 16c plus 7. And now all we have to do is just substitute this whole thing into f prime of c, and we'll just do 333 minus 12, which is 321, divided by 3, because 5 minus 2. Then we're going to get a value of 107 here, minus that, and we're going to get 12c squared minus 16c minus 100 is equal to 0. And as we solve for the zeros of the function, we will get c, and I'll just erase this part. So right here, the c here, the c is going to be equal to negative 287 divided by 125, and c, there's two values of c, and 3,629 divided by 1,000. So two values, one's negative, one's positive. So two values here satisfy the mean value theorem between this interval. And as you can see, there's no negative value, so we can cancel out this c value. And this value is between 2 and 5, which is 3.629. So this value satisfies this question. If it was an open interval, then we would have used, we can't use an open interval because it has to be a closed interval, because in the definition that we put for the mean value theorem, it says it has to be continuous on the closed interval and differentiable on the open interval. But that is the end of this video. I hope you learned the mean value theorem and Rolle's theorem better, but if you have any more problems in calc, let me know down in the comments, and leave any suggestions for any topics. After this, I'm doing curve sketching. Check out that video. Before this, I did horizontal and vertical asymptotes, and check out my whole playlist. But that's the end, and nitty gritty out.